Why?
You get the screen on black, and then it had like a message in there.
Oh, I see. All right. I thought I had on airplane mode. Oh well. I thought maybe it reached its profanity level. Shit. No?
Do you upload it every night?
Yeah, immediately after class.
All right.
So, you got completed square. You have just the straight up square rooting if there's a square. Right? And then you have quadratic formula. And you always have in the background, the first thing you really should try is, does it factor? If it factors, you shouldn't have to do any of that other weird stuff. Right?
Can you do one like that?
Factoring?
Mm-hmm.
Sure. Let's see. Sure, that looks neat. So this will factor. Not that terrible. Factors of what that add to be what? Okay.
That multiplied by
It's not what I asked, but that's the answer. Factors of
60.
negative 60 that add to be negative 7, right? I mean, that's how you factor this thing. So that would be negative 12 and 5, right? That would make negative 7 if you add them. It makes negative 60 if you multiply. So whoever said that, I'm not coming down on you. Sorry. That was beautiful. Got the right answer. But I wanted everybody to kind of come with us. And then what do I write?
X minus 12, X plus 5.
Yes, and why is that nice? Because now I just say x is 12, or x is negative 5. That's what makes those 0, right? Can you imagine? I don't care how quickly you can do quadratic or complete squared. It would have been a lot longer than that. Shit. So you always take a second and try factoring. Maybe you'll miss it. Maybe you won't get it and you'll think it won't factor. But so when you do the quadratic, these numbers will come out. Quadratic will work on this. It's just, it'll simplify a lot further than what we got there. The square root will be doable. Does that make sense? Let's try this real quick. And then we'll get some new stuff. If I use quadratic on this, what would it look like? What's A, what's B, what's C?
A is 1, negative 7, and negative 60.
Negative 60. Oh, shit. All right. So then you get x is negative b, so 7, plus or minus square root of b squared. For some reason, people put that. No. The negative dies. Negative 7 squared is positive 49. Shit. Minus, got it, 4ac all over twice a. So I get 7, give or take, square root of what? $289 to guess. Believe it or not, you can do that. Huh? You can do the square root of 289. 17. Kick ass. So this is 7 plus or minus square root of 289 is 17. How many answers are there? What's one of them? 7
over 2. No.
7
Plus 7.
plus 17. I can do 7 plus 17 over 2. What's that?
That's 12. 12.
Is it? Yes. Because you get 24 over 2, which is 12. Kick ass. And what's the other answer? 7 minus
5.
17
Negative 5.
over 2 is negative 10 over 2, which is negative 5. So, I mean, and this is why people sometimes always do this, because they suck at factoring. And this is bad, because factoring is actually important. You need practice at it as much as you can get. Cool, because there will be quite a bit of factoring on the finals. The door out will have a lot of factoring to let you through. Right? Okay. So don't get too excited about this. Oh, yeah, never have to factor again. Okay. So, again, every single method is summarized on a little sheet there. So make sure you got one of those. All right? So I summarize all the different methods. In the homework and on the test, I will sometimes say, use this method, and I will sometimes say, solve it, whatever the hell you want to do. So you have to be able to do all these methods. Okay, cool. So let's get into some new stuff before we run out of time. Today we're going to look at what I was saying earlier. We're going to actually come up with a way to find the vertex quickly. Because the vertex is just about the most important point. The next most important points would be the intercepts. But the most important point is where that bad boy turns, right? So very often we say the economy is shrinking at a less rate. So it's still going down, but it's not going down as much. So maybe it's going to turn. That's why the economists get excited. Maybe it's a turning point, or maybe it's going to go, ha-ha. Right? So when you hear that in the news, it's the rate at which it's decreasing has slowed. What the hell does that mean? It means it's still going down, but not as fast. And we're all hoping it's going to turn. Right? Okay.
Wait, sorry.
Yes.
What was the section we just did?
13.2. So I don't know if you guys realize, but just to remind you, we go straight to 13.7. Just because the rest of it's not in our curriculum. This book is for 103 and 110, so they do some other weird shit in the middle. We go straight to this. So let me see if you guys are cool with this in here. This is where we get a little bit more interesting. And this is bringing that completing the square back in. And let me actually start with, let's see. Let's do this. Let's do some graphs by hand real quick. I know you guys are excited about that. All right. So I'm going to do this with you, so we can go relatively quickly, because I want to make a point about this. This gets really interesting about graphs. So if I go to graph this, and just a note, if I had y equals x squared, it's what I call the base function. That's your basic, classic parabola. You guys kind of with me? Y equals x squared, there's no other weird pieces to it, it's just y equals x squared. There's nothing else going on. It's the basic, stripped down, bare bones parabola. This sucker is going to look like 0 squared is 0. 1 squared is 1. Negative 1 squared is 1. So this is the base parabola. Now what this and this are going to do with that are they're going to move it. They're going to move it up and down, or they're going to move it left and right. Right? Move it, move it. So if I do f of x first, you guys will catch on pretty quickly. Let's do these three basic points again. Negative 1, 0, 1. What do I get when I put a negative 1 in there? What's negative 1 squared?
1.
Plus 4? 5. 0 squared plus 4? 4. 1 squared plus 4? Okay, cool. So this would be negative 1 goes to 5, and 1 goes to 5, right? And 0 goes to 4. So can somebody tell me, how does this visually compare to this? I picked this up and I did what with it?
Shifted up.
Moved it up by how much? 4. It's crazy. And look at the freaking equation. The equation's saying, hey, take x squared and move it up 4. Oh my God. You guys see that? So if I would have put a minus 3, it would have taken this and went down 3. It's insane. So when it's outside of the x like this, when it's outside of the x, it's going to move up or down. It's going to take whatever that is and add or subtract to that output. How are we doing there? Is that cool? All right. What about this dude? So you guys might kind of know what that's going to do, but let's pretend like we don't. And let me just kind of get to the point and give you some nice inputs. Let's do negative 3, negative 2, negative 1. Negative 3, negative 2, negative 1.
Oh, there we go.
So when you put a negative 3 in there, what do you get? With negative 1 squared, which is 1. Put a negative 2 in. Negative 2 plus 2 squared, still 0. When you put a negative 1 in, negative 1 plus 2. Negative 1 plus 2, 1 squared, 1. So then that looks like this. Negative 1, negative 2, negative 3. At negative 2, it's 0. At negative 1, it's 1. At negative 3, it's 1. So compare that to this. What happened? I took this and I shifted it
Left.
back or left 2. Kick ass. Because look at this. What makes this 0? Negative 2. Because what makes this 0? 0. So that's why it was there. What makes that 0? Negative 2. So that's why it shifted back. If I put an x minus 2 in there, where would this go? Over this way too. Neat. Now, I'm not going to get any deeper than that. This is called transformations. And we can do stuff like flip it and stretch it and all this kind of weird shit. And we can see what mathematically, but we don't need to do all that. And if you're interested, you can ask me. But this is all I'm going to worry about right now is a shift up and down. If it's outside of the x, if you can do that and find x squared again, that's going to go up or down. If it's inside with the x, it actually kind of goes the opposite of this. Plus 2 made it go back 2. Minus 2 would make it go forward 2. Because you have to think about what makes this 0. It's going to be the opposite of that. All right. Yes, sir.
So for the one side, you just plug in the negatives, and for the other side, you plug in the positives. Right? For the x and the y.
Yeah, the reason I did this is because I knew ahead of time that negative 2 was the important point.
No.
I knew the vertex was going to go to negative 2. So that's why I picked those points. Cool.
Okay.
But I was more interested in the visual effect and then working backwards as to what happened instead of figuring out what happens before we saw the visual.
Actually, what I'm trying to say is that you plug in negative numbers for one side, and you plug in positive numbers for the other side, right?
How do you mean?
See, for the x, you got negative 3, 2, and 1. And then for the y, you have 1.
He's saying that you have negative numbers of x and positive numbers of y. That's
Yeah,
what you mean,
sure.
right?
Yeah. It's like it's
No. I didn't plug these in.
Oh,
When I put a negative 3 in, what do I get out?
negative 3 plus, okay, negative 1. Oh, yeah, okay.
Okay, all right. So this is the basic idea of an XY table, right? These are normally my inputs, and these are my outputs.
Okay.
Cool. So maybe you thought we were doing something brand new. No.
I was confused, yeah.
I can give you a funky looking function, and what do? You make an XY table. You're like, I don't know what the hell this thing does. Let me make an XY table. Right? I like it.
You could use any numbers, right, when you use that?
Totally.
Okay.
But the more you understand about, I mean, obviously I don't want to use like 20.
No.
Unless this was x plus 20. Maybe then I want to use negative 20. Because I have to know ahead of time where this guy wants to be so I can know what inputs to put in there. So the more you understand about what this kind of thing does to the graph, the better you can pick the right inputs. Okay, cool. But we just don't do a lot of graphing here, so you don't really get that. That would be 110 and then 176. Those would do the graphing. Okay, so what I'm trying to say is, if I have this, we have the picture right there. Where's the vertex? 0, 0. Is that cool? I mean, that's 0, 0. That's the base. It's the home base for the vertex. When I start doing stuff to it, it's going to move around. So if I have this, let's see if you guys can get this. Make this worse. Where would the vertex be for that? What would it look like very quickly? It wouldn't, here's what it is. This is what that is. Where would this take it? It would take it down 2, right?
Yes.
So now it would be here. So where's my vertex? 0, negative 2. And think about this. This is a weird question. Let me write this down, and then I'm going to ask the question I was about to ask, because it'll make a little more sense. What about this guy? What would he look like? Where would his vertex go? Let me see if you guys remember. So here's the base function, and then it's going to move which direction? To the right, because what makes it 0? What makes it 0?
1.
1. So it's going to go to 1. It's the opposite of what it looks like. So now it's going to be here. Vertex is 1, 0. So watch this. This is kind of cool. You ready? And you're all like, oh, this is the cool part? If it's out here, that is the y-intercept. In fact, we've known that forever. Y equals mx plus b. B is the y-intercept. Actually, it's the same thing here. Make x 0. Look what I get. Yeah, it's the y. But actually, let me extend that. What if it's out here? That's the y piece of the vertex now, because maybe this won't be 0 here for the vertex. So if it's out here, that's the y piece of the vertex. If it's in with the x, that's the x piece of the vertex. So watch this. What's with the x? x plus what? What's there? That's a weird question, I know. But what am I adding to x inside here? X plus what? What's in there?
What?
Weird ass question. Nothing.
Oh.
0. That's why that was a 0. So let me put it all together for you. So here's our first quick way to find the vertex. And you'll quickly see that it's not the quickest way. If I had a function, if I had a parabola that looked like this, the vertex, now combine them. Look at this, it's doing everything. Shit, it's moving all over the damn place. Where'd it go in the x piece? Where's the x piece go? 3. 2. There, done. Vertex is 3, 2. So if I can get it, and I want you to realize, this kind of idea goes through a lot of different graphs. Circles, ellipses, hyperbola, all this weird shit. If I can put them in a certain form, I can see certain things about them. We know this already. If I put a line into mx plus b form, what do I see? The slope and the y-intercept. If I put a parabola into this form, what do I see? Vertex. Yes, sir.
Why did the negative go up?
Because again, what makes that 0?
Oh,
3. And that's what it's going to move over to the right. 3. I like it. So some of you guys might be savvy enough to realize, if it doesn't look like that, how do I make it look like that? Let me say that again. If it doesn't look like that to begin with, hey, back there. If it doesn't look like that to begin with, how do I make it look like that? I got your attention. So if I have this, does that look like that?
No.
Shit. How do I make that look like that? What process do I have that will take the x's and make it look like that squared? Maybe it's a process we did earlier today. I don't know. What process do I have so I can make it look like that? Maybe some other stuff. Huh?
I don't know if it's quadratic.
You move the 1 to the other side.
Yeah. Is there really another side?
Oh, there's no other side.
I like it. Good. All
What am I
right.
talking about?
So stay with me.
Is that what it is?
Who still has car alarms?
That's like, oh,
Does anybody feel like running? Is that building?
That's in the building, isn't it?
Yeah, it does sound. Yeah. It's probably the science building. Maybe they have a fire in one of the chem labs. You did it! I'm saving you. Wow. It's crazy. How are we ever going to find out? Open the door. Okay. Alright. So, stay with me now. This is going to be just a little different. The steps are the same, but I don't have two sides, like Anthony just found out. I don't have two sides to this damn thing. So everything's got to happen on one side. So this gets a little bit free. Stay with me now. What are the two steps to complete the square? Let me at least do this. I can at least move one over a little. Get over there.
Have that thing. Did you want to say it? My bad.
No, I was going to say something else. But
Yeah, because what are the two steps?
divided by 2 and then
Yeah, take the middle term divided by 2, and then square. So what do I do with the 9? Now here's where I need you to go with me here, and this is what I always think about with Indiana Jones, for example. Y'all seen the first movie? Indiana Jones? I know, you're like, it's before I was born. Yeah, they have DVDs and shit. You can actually get it online, free or pirate it, or whatever you want to do to get with it. Yeah, so remember the scene in the beginning. He didn't do this right. He didn't balance his equation correctly. But he had a little golden idol. He tried to figure out how heavy it was. Now, if you take something away, you better add something onto it so you counterbalance what you did, right? He just didn't add the right weight on. He took 8 away and gave it 7. Oh shit, Indy. Math says screw you, and a boulder comes and kills you. Right? Of course, he barely skipped it. Otherwise, there'd be no movie. So, if you've never seen it, what the hell? Get up and try. So what do I do with the 9?
you add it.
Now watch. I add it here. I can't really add it over there. There's not really a side here. So at the same time, if I add 9, I better at the same time take freaking 9 away. This always freaks people out. But overall, what did I just do? What did I just do? Overall, nothing. Yay, Jeff. You did nothing. Good job. Do you understand? What is 9 minus 9?
0.
So did I change this side? That's why I don't have to do anything on that side. I didn't change the side. I just reorganized things. Because now what can I do with this? What can I do with this?
Big 2 negative 2? No.
Yeah, so that goes there so that it can factor like this. X plus 3 squared minus 10. Shit, so what's the vertex?
Oh, 3 negative 10? 3 negative 10?
Mm-hmm.
No.
Negative 3. Negative 10. So in general, if it's inside with the variable, it's the opposite. If it's outside, it's exactly what it is.
Wait up till
Desperately try to make sure you understand why that is. But the way you think about it is what makes this 0, and then this is just that. That's where the vertex would go.
This makes so much sense.
Okay. So if I plotted this thing, that's the lowest point. How do I know this parabola opens up? Does anybody know how I know this parabola opens up?
because it's positive?
Because right here, this is a positive. Cool. If I would have put a negative sign there, it would have opened down. This would have been the maximum. That would have been like a profit function, right? Nobody's profit function is like that. They wish. What's the maximum? It goes up forever. No, sorry. Don't care. It's what you do. All right. So, last thing I want to show you, in the little tiny bit of time I have left, is I want to desperately try to show you a much better thing than that. You're still going to have to know how to do that. But here's a kind of a better shortcut. If I had a function where I knew the intercepts, like, can somebody tell me what the intercepts for this is? Are? Whatever grammatical word goes there to make it work. What would the intercepts be for the x-intercepts? Yes, it's one of them. And 6 is crazy. Right, what makes it 0, 2, and 6. Now, what is something about parabolas? So here's 2 and 6. So I know there's an intercept there, and there's an intercept there. Every time we draw on this parabola, there's a certain definite property to a parabola. It's symmetric. The vertex is going to be right in the middle of any 2 points that are across from each other. So if I know the intercepts, can anybody tell me where the vertex is going to be? What's the x piece of the vertex? So it's got to be where related to this. So if I draw a parabola, here are the intercepts. So where's the vertex? Right in the middle. Shit. So what's right in the middle of 2 and 6? No, wait. So how do I? So I know it's somewhere here. I know the x piece is 4. So if I know, are you guys kind of with me still? So if I have any 2 points that are across from each other, vertex must be in the middle because the whole thing's got to be symmetric. There's got to be like a mirror right in the middle. So I'm using the symmetry of it. Okay, cool. If I know the x is 4, how do I figure out what the y is? How do you always do it? If you know an x, how do you figure out the y? You just plug it in. It's crazy. So what's f of 4?
So 2 times negative 2, negative 4.
Crazy. So now it's going to be 1, 2, 3, 4. So the vertex is going to be 4, negative 4. Kick ass. Bam. Bam. You with me? Now, here it is. Here it is. The ultimate. The ultimate. Because can I always factor it easily? Shit. What do I do if I can't factor it? What do I do if I can't factor it? What method do we have that we can use? Quadratic formula. Kick ass. Now watch this. If you guys get this, it's awesome. Here's the formula. Let me write it a little bit better. Here's what the formula looks like traditionally. You just do one little tiny thing to it. No, Jeff. Not big old thing. Is that cool? I can just split it up. Is that all right? Negative b divided by 2a plus or minus that divided by 2a. Now, why do I do that? Because this would represent the intercepts, right? Now, look. This is a bunch of shit here. So let me see if this helps out. Screw it. I'm not going to do that. Unless you guys get this. How do I get through the intercepts? What do? I start at negative b over 2a, and I add this to it, right? You guys with me? If I add that to it, I end up here. There's an intercept right there. This would be negative b over 2a plus this. And how do I get the other intercept? Subtract the same amount. And there's an intercept, right? So if the intercepts are exactly equally spaced around this, where's the vertex going to be? Right here. Holy shit. There's the ultimate shortcut to finding the vertex. The x piece is negative b over 2a. That is the formula for finding the x piece of the vertex. Well, if you have the x piece, how do you get the y piece? Plug it in. So watch. If they would have given me this in this form, that's what I get when I multiply that out. Are you guys with me? What do you get when you do negative b over 2a? What's negative b? Over twice a. I get 8 divided by 2 is? 4. 4. So when you can't factor it, when you have this but you can't factor it, you can use this. Negative b over 2a is the quickest way to find the vertex. It kicks so much ass. Right? That's an awesome shortcut. That's plenty. I love you guys are all like on the edge of your seat. Stop talking. Okay, I stopped talking. See you guys Thursday.